It's useful to know how to solve exponential equations because they can be a little bit different from other types of equations. But if we get used to them, we'll be able to figure it out easily. A lot of the time we'll have to deal with percentages, and the first thing we need to remember is that a percent, to change it to a decimal, we need to move that decimal place over 2 spaces. So 4.2%, let's say, will become 0.042. Or let's say we have 32%, that will become 0.32. One thing we'll have to deal with exponential equations are annual increases or decreases. These are also called growth or decay problems, an increase for growth and a decrease for decay. We can show these growth or decay factors by either subtracting or adding the annual rate, or r, to 1. You can see the basic growth or decay equations here. For growth, y equals a times 1 plus r to the x. And for decay, y equals a times 1 minus r to the x. For example, if something decays in value by 10% each year, the decay factor would be 1 minus 0.1, because 10% equals 0.1 in decimal. If we have something that increases by 10% each year, though, the growth factor for the equation is 1 plus 0.1, or 1.1. The other thing in this equation is a, which is the initial amount before measuring the growth or decay, and the x is a number of time intervals that have passed, which often will be years. Let's look at a real-world situation to get an idea of how to solve this. The population of Jacksonville was 3,810 in 2007 and is growing at an annual rate of 3.5%. If this growth rate continues, what will be the population of Jacksonville in 2020? The first thing we need to remember is to convert that percentage into a decimal. All we have to do is move the decimal place over 2 spots. So 3.5% equals 0.035. That's going to be our r in our equation. Since we know that we're dealing with growth, we can simply plug in our values to the growth equation. Y equals a times 1 plus r to the x. So y equals 3,810 times 1 plus 0.035 to the x. The last thing we need for this equation is our x. Here's the number of years that have passed. We know that we're trying to find the time change from 2007 to find the new population in 2020. We can just subtract those numbers to find the difference. 2020 minus 2007 is 13. Our x equals 13. We know the initial population, a, and now the only thing we have to do is find our final population. Our final equation is going to be y equals 3,810 times 1.035 to the 13th power. When we plug that into a calculator, we get 3,987. That means that in 2020, there will be 3,987 people in Jacksonville. Let's look at one more example of a decay problem. Each year at the local country club, there's a tennis tournament. Play starts with 128 participants. During each round, half the players are eliminated. How many players remain after 5 rounds? Our basic decay equation is y equals a times 1 minus r to the x. What's r here? Since half the players are eliminated each round, r is 1/2, or 0.5. We know that there are initially 128 players, and that's the a, and there are 5 rounds, or intervals, so x equals 5. We can now plug everything in to get y equals 128 times 1 minus 0.5 to the 5th power. We plug that into a calculator, we get y equals 4. That means that there will only be 4 players left after 5 rounds.